Howdy, howdy, howdy. Sorry, just trying to finish something up. How we all doing? Sometimes VS Code's autocomplete is quite annoying. Okay, it's 1 o'clock. We should probably get going, huh? Oh, why do you insert so many extra parentheses? Grr. Okay. Alright, good enough. Sorry. Okay, good morning. Monday blues. Monday lo-fi hip-hop beats, you mean? Alrighty. This is some other stuff we got going on, y'all. So, I hope you all had a wonderful weekend. Go over here, please. Thank you. Enjoying the last second summer that we've got here. It's supposed to start getting cold again soon, so if you can get out, I would take advantage of it. And if you can't, hopefully you can at least open a window. It is gorgeous outside. Alrighty. So what we are going to talk about today is we're going to review the patterns that we talked about already to make sure that you're all kind of aware of how to use them and why we use them. And then we're going to talk about some anti-patterns because those are honestly quite fun to consider because these show you everything that has gone wrong with software engineering over the past 40 years or so. So basically it'll be a lot of fun. Might see that I'm back up in my office again. Jeans and hoodie is not the move today. Absolutely. There are a lot of anti-patterns. Had a bit of an emergency over the weekend, so my angry girlfriend no longer has a leg. Somebody knocked it over. Oh, and I know there's one of you that are working on a smart mirror. I don't know if you'll be able to see this, but it's a little bit too far away. Maybe I'll get my horrible... There we go. So, I've got a little e-ink display that I've set up with kind of a custom magic mirror software. It's not the real magic mirror. You can do it on e-ink, but it's not what I wanted. So the cool thing about that is that I can yank the power and the screen will stay on because it's e-ink, not an actual display. But it pulls the weather, pulls the calendar, pulls the schedule, and kind of nifty. So similar to the Team Smart Mirrors project that they have going on. But it's just a picture frame with a Raspberry Pi and an e-ink display in there. Something I did, I think, over the summer. It's a birthday gift, maybe? Anyway, let's talk about patterns. So today we've got some slide-dos for you to answer. Basically, I just want to make sure that you understand what I've been yammering on about for the past week or so. So we started with Singleton, right? Looks kind of like this. Pretty straightforward class diagram. You have a private instance variable, you have a private constructor, and then a public call to get instance. So my question for you all is, what is Singleton and why would you use it? I just want to make sure that everybody is on board with some of these. Make sure this is still working. And I realized, oh, we'll yank it off of Twitch later. Forgot to hit record. Yeah, this worked flawlessly in the morning, so hopefully it works again right now. So what are we thinking? The is from me. Can be used in place of global variables, so var names aren't muddied up. Yeah, that could be one where you could use that. Use it like a global cache of data. So there is a pattern called data cache. It's very different, but you can use it as basically a reference object. Absolutely. So one of the things that we talked about using it for was a random number generator, right? So that would be something where you need the same object used in multiple places. And a singleton is going to give you a couple of things. It's going to, yeah, a single reference of an object. Basically, you can be sure that everybody is using the same object, which is good for consistency, right? So that's definitely a good thing. But you can also use it for memory optimization too. The example we talked about for this was instantiating like enemy characters or something like that, right? So if you know that you're only ever going to have one type of object in your game, for instance, well, just make it a singleton. That way you only ever are taking up one block of memory for it. And then you just copy that reference wherever you need it. Um, a better use of that though might be because if you're, let's stick with the game example. Let's say you're writing a game, you're going to have multiple types of enemies, you have multiple sprites, you have multiple objects. If you're doing a 3D game, you have multiple, models, all of that fun stuff. But if you're doing a 2D game, you might have a single sprite sheet that everybody uses, right? So that's one big image with a bunch of little graphics baked inside of it, so little sprites. Do you need to reference that 100 times? No, create it as a singleton. Then you can always be sure there's only ever one copy of that. And when you start dealing with things like loading images, you definitely want to make sure there's only ever one copy of that. There's another pattern like singletons that just copies data from object to object less efficiently. Interesting. Yeah, I'd be interested to know what pattern that is if you can come across it. It sounds like it could be useful. But yeah, singleton, easy pattern, right? Nothing too crazy here. If I gave you a class diagram that looks like this, I'm sure you could all easily implement it in whatever your language of choice is. So good job. All right, so we also had Facade. This was the second one we talked about, right? This was another fairly simple type of design pattern where we have a client, we have our facade, and then we have a bunch of, we call them complex objects, but basically they're just kind of specialized components, right? So client has a reference to facade. We call facade.operation. Facade's operation does a bunch of things with these components. We have a nice separation here of objects, right? So the client has a nice separation from the complex objects. So the follow-up question here then for you is, what's a facade and when would you use it? And the goal here is not to force you all to interact. It's more to make sure that you understand when and where to apply these things. This really will set the stage nicely for the last quarter of the class when we talk about anti-patterns. So I might have to start doing this. Why do we use a facade? Interface with complicated functions in a similar way. My poor gimped crow. Class that runs all other associated classes for convenience. Yeah, exactly. So I'll come back to this if you're all still popping your answers in, but exactly right. We are basically obfuscating our code from the client. We're abstracting it away. So if you have a simple, normal set of operations that always has to be performed, and you don't want the client to worry about that, and again, the client is just whichever entity is interacting with your system, have a facade. The facade takes care of these operations. Singleton. Halfway down called a Borg. Ooh, that's a good name for that. Borg Singleton. Huh, interesting. Cool. I've never heard of that, but that's good to know. That's a perfect name for that though. I love that. All right, so facade then. So you were all talking about that. Yep, okay. So if you remember, we had the washing machine example for that. Basically, you have a set of operations that you can call, and the client doesn't care what they are. He just wants the washing machine to run and do things. But if you're a power user, right, let's say that you are hacking your washing machine, you are hacking whatever object you want, or you're an experienced programmer and you want particular things to happen. Our example was let's turn it into a energy efficient washer where you run the spin cycle at such and such a speed for so long, and then maybe you do a load check and you see how much the thing weighs and all that fun stuff. None of that is privated out, right? None of it is hidden. You still have access to all of these complex operations because they're still public here, right? The client could, in theory, instantiate complex object 2 and call its functions. Facade is basically a useful interface to the rest of the system. So when you use NumPy in Python, are you using a facade? You could make that claim for pretty much any library in a way. Yeah, so you're basically treating the library interface like a facade. Now, the only difference would be, though, that the facade would take care of all of the operations for you. So this would kind of like calling NumPy and doing a normalization, or if you're doing a distance calculation or something like that. Right? NumPy knows how to do all those calculations, and you just call NumPy dot normalize, I think it is, or something like that. So yeah, that basically would be it. All right, so good. Facade makes sense, I think. Next one we talked about was observer, and I'm not going to make you do a slidey for this. You will for visitor coming up. But observer, if we remember this one, this is where you have some class that's under observation. We call it the subject. And it can go through changes. So it might have some internal state that's changing, some variable that's changing, or heck, maybe it's watching something else and that thing changes and tells the subject, now there's an update. Well, the important thing here is that the subject will notify any observing class that this change has occurred. So we will tell whoever is currently attached, right? So we are going to attach and detach observers that this state has changed. This is what we are at now, right? We have gone from washing to rinsing. Notify your Twitter API, notify the dryer to start warming up, things of that nature. But the key thing here is that we can have multiple subjects, multiple observers too. So we might have multiple concrete subjects, right? They're specializations. Maybe they're different types that we're watching. Same with observers. They don't all have to be the same class. They can be specific instances. But the key here is that we are attaching an observer type, and that observer type will get notified if a set of conditions gets met. So instead of like we're watching it, we are being notified. It's basically like a push notification in a way. But the subject is in charge of notifying the observers, not the observers watching the subject. When would you use it? Whenever you need to notify something, notify a class that something has occurred. Hopefully pretty simple. Again, the diagram's getting a little bit more complicated, right? So we have more things going on, but it's still pretty straightforward, right? You have a subject, you have an observer. If you attach an observer, it can be notified while it is attached. When would you detach it? When you no longer care about the updates. So hopefully that makes sense. The interesting point, though, is could we use this with something like MVC? So we'll go back into MVC in a few moments here. Is this what's going on behind the scenes with listeners in Java Android Studio? So a listener is basically waiting for an event to occur. See, the thing is, I know that listener is a very specific construct, so I could see where it would be considered an observer pattern. I want to say there's something specific with the listener that it's not called an observer, though. And if anybody wants to look that up and see, to me it would be an observer because you're listening for an event to happen. When that event, no, it wouldn't. No, it wouldn't, because it's waiting for an event. The flip side is that we're pushing that event to the observer. It's not the observer listening for something, it's the subject telling the observer something has happened. I guess it just depends on your perspective with a listener, because I could argue it both ways now that I think about it. Yeah, tricky. Very tricky. It depends on who your subject is, I guess. Okay, so could you use it with MVC? This is an interesting question. And it kind of ties in nicely with, can you apply multiple design patterns, right? Because we have a ton of them. Why could we only use one? Well, you can overlay them, absolutely. So we have an observer here, and let's say that we're implementing a model view controller framework on our, I don't know, our web application or a Java Swing application. If something happens on your backend, right? So your database or maybe a text file has changed, that could be your subject is the model. If something triggers in that model, notify all the views that are associated with it, right? We have added a new product to our inventory. Well, tell the view that is attached to update. And what is that view? Maybe it's an email, like a list of email addresses, where that view is watching to see if something has changed, blast an email to all interested people. Like those suggested purchases you get from Amazon or any of the online retailers. So by all means, overlay multiple design patterns, as long as you don't break their functionality, as long as you don't like break anything. Right? For instance, if we go back here, can we overlay a facade and a singleton at the same time? Well, sure, but we can't violate the singleton principles of only one instance ever. I guess you could cheat with this Borg pattern, but then it would be a Borg pattern, not a singleton. All right, next one up, visitor. So again, reviewing here a little bit. But if we remember from a couple classes ago, we talked about the visitor pattern. This one got a little bit more complicated, right? It was a behavioral pattern. We are doing things at runtime now. It's not just structural or architectural or creational. This is actually influencing program behavior. Now, this diagram looks a little bit different than what you might remember, but it's the same thing, it's just laid out differently. So you still have a client, you still have an object structure, and again, this is just our object that we're watching, but we still have our visitors with our specializations for the different concrete ones, right? So this might be your XML parser, this might be your TXT parser, CSV parser, JSON. That's the example that I was thinking of. Then you have your elements, right? So these are your different objects. They need to accept some visitor for each of them. And we specialize down into specific elements. If you remember from when we talked about it, this was also known as visitable. So visitable, kind of enunciating weird just to make sure that it's clear. It was elements in the diagrams, visitable in the slides. Basically, it's the same thing. It is something that can accept a visitor. And you'll notice that they each have accept functions to bring in a visitor. And we don't care what the visitor is as long as it appropriately matches what the element is expecting. So, last slide for today. What is it and why would you use it? So this is kind of, again, an important distinction of knowing the definition, rote definition, but why would you apply it? One of the key things that we think about here is the trade-off in software engineering. There's always going to be a trade-off. And what I'm talking about here, and I'm just talking while I'm waiting for answers to come in, is the cost of implementing one of these patterns worth the benefit that you get? Right? If you add this pattern now, are you saving yourself development time later? If you don't add it now, you're saving yourself time now, but maybe you're leading yourself down a path of technical debt with tons and tons and tons of maintenance. Visitor pattern determines which subclass data goes to. Use it so that each new data type can be easily added, new subclass for each new data type in the future. Yep. So we can very easily add things on to pre-existing classes. And the definition I think we gave before was that you have some fixed class where you can't add new things. Right, so think of like a library that you're bringing in or some kind of an API that you're calling. Basically, some object you can't easily change, but you want to add new features, new behaviors, new classes, new objects. How do you do that? Well, let's wrap it in this visitor pattern. Let's bring in new algorithms that it wouldn't necessarily see before, but by simply calling its .visit function, we can execute whatever is in this other class. And we get this through some cute, basically inheritance and associations and double calling this visit function. So it can be a little bit cheeky with our class associations, basically. Makes, sorry, I'm not trying to flip through, I'm trying to get back here. Makes life a little bit easier. All right, so good review. Now we're gonna finish off this little review with MVC and MVP, and I know we talked about it on Friday. And the interesting thing here is that I want to really stress the point of why we would use these things. So MVC, MVP, whichever one you want to implement, we are very strictly setting apart our responsibilities. So the model only cares about your data set and how it is manipulated. It does not care what the user clicks. It does not care what the internal logic of your application is. It just is responsible for this data model. The view doesn't care about the database. The view doesn't care about your internal logic. The view is just presenting data, handling user interactions, and we have a little bit more power with MVC, I should specify as well. MVP is very similar, right? These are basically two very, very, very similar patterns. The key difference with MVP, though, is that there is a very, very strict separation between the view and the rest of the system. The view is strictly passive. It is a dumb view. It only shows information. Okay, in MVC, the view might have a little bit more power. It's possible to talk to the model directly in MVC. That is something that we can do. We can bypass the controller possibly. Depends on the application and how crazy you want to get with it, obviously. But there's the possibility there. In MVP, there is clear, distinct separation of responsibilities. It's called a passive view because it's literally passive. Handles the user events and displays data. The presenter is going to be basically a little mishmash of your old view and controller from MVC. We have routing capabilities, we have state changes, things of that nature in here. Basically, it's just a little bit more powerful. We're moving the responsibility from the front end to the middle, effectively here. So if you're looking for why we would do this, that's the distinction. The view is 100% passive here. And when would you use them, and why would you use one over the other is kind of an interesting question because they're so similar. You know, I've talked about this in terms of games. I gave like the Amazon example from last time. But you would use this when you have a complicated application that is user-centric. So would you use this if you don't have any kind of an interface, like a user interface? Probably not, right? Because you don't have any views. There's no browser, there's no application front end. It's just, you know, things happening behind the scenes. Why would you use MVC or MVP? Doesn't make sense. But if you do have that, and the application is complicated enough to merit this overhead, then implementing it will save you a ton of time in the long run. So you can have people working on the views, the models, controllers. They're all separated nicely, right? That's kind of what we talked about last time. With MVP, you might consider using that because it's actually easier to test in a way. So why do I say that? MVP gives you a very, very simple user interface, right? It only cares about displaying data, displaying information. In theory, you can test that a lot easier. We haven't really gotten into testing yet, and that's coming soon, I promise. But if you're testing user interfaces, you're probably going to be doing like a lot of automated clicking, filling in fields, Are the views rendering to screen appropriately? Things of that nature. And if you have extra logic baked into your view, like if you're doing an MVC type of thing, it gets a little trickier to validate. You might have to run additional unit tests. You might have to do lots of extra stuff. Whereas with MVP, the testing is a lot simpler at the detriment of taking that responsibility and putting it elsewhere. You still have to test it. I mean, it's not like an easy, free solution, but it separates things out a little bit nicer. So we have these examples here. And when and where would you use MVC? Very nice for web applications, very nice for, again, any kind of a GUI application where the cost of implementing it is far outweighed by its benefit. Again, think of a very simple web application. You probably would not use MVC unless you want to learn it. There's a lot of overhead in terms of files, in terms of learning curve that goes with MVC, but it makes life easier in the long term. So I showed you CodeIgniter, that was a PHP framework. There's also Cake PHP, also MVC. If you don't like PHP, which is perfectly fine, you could go Python-based. Flask and Django are both MVC frameworks. Ruby on Rails if you want to go down that route. You've got Struts, which is Java, I believe. ASP or C#.NET, so Visual Studio.NET now. Basically, there are a lot of frameworks out there for doing MVC that take all of the burden off of you, the designer. So how do we implement this on a website, for instance? I showed you CodeIgniter before, so hopefully this is review, more or less. But your view would be what's rendered, right? So that's going to be your browser. It can be your HTML code, your CSS code, any JavaScript that you have that is client-side. That's your view. Now, could I add different views, right? So different web pages, different interfaces? Absolutely. This is all nicely separated out, where this might not be a browser. Maybe it's a Raspberry Pi running a terrible, what is it, Midori? Or there's like a light version of Firefox now that's valid on there. But you would have different views for different rendering scenes, right? This could be a phone with an HTML context rendering the web page. Maybe you're providing script support, so the view is actually robot readable text, not nice, pretty form elements and animations happening. Or you could do accessibility views, right? Screen reading support is a wonderful thing for websites. That could be a different view that you present to somebody accessing it with a screen reader, for instance. So that's your view. Point is, you can easily swap them in and out. The model, again, this is your database, this is your backend. The controller, this is what translates data from the view to the controller. Now, on a website, that's going to be like a post or a get call, which is typically what you see if you click a form button, like you have a form of data and then you click submit. That would go through a post usually, or a get call. The controller knows how to route that. Or if you go to different URLs within the same website, you would be routing to different pages. The controller would be handling that routing. Which model is tied to this page? Okay, render this view. So we're doing translation here. One thing I should point out too, if you're just looking at this and not listening to me at all, browser and server here look like they're two entities, not three. There is still a very clear separation between controller and model. They just happen to be on the same machine in this case. So don't think this is like one entity and this is one entity. This is your computer. This is the web server. So I alluded to this point earlier as well. With MVC, it's possible to skip the controller. So you just have like MV, basically. Now, why would you do this? This sounds horrible. You don't have that nice controller layer. Well, if you don't need translation, right? If you don't need anything crazy, like maybe you're just dumping a database to your website, or you're dumping the contents of a JSON file to your Android application, there's not really a need to translate or route anything. Just call the model directly from the view. This is where we might consider MVP to be a cleaner implementation, because in that case, the view would not be allowed to do this. here it is. However, I would kind of argue, though, that if you're doing an application complicated enough that you need MVC, you're probably going to have a controller anyway. Just kind of the reality of things. So here we have another example too. So multiple browsers, so Firefox, Chrome, Internet Explorer 6, Raspberry Pis, Midori, accessibility reader, your Wii rendering a web page, Xbox, etc., right? Still controllers, the same model, the same multiple views. I've got a question here at the bottom. Why not use MVP for the web? You could, right? I mean, there's nothing stopping you. At one point, there were some arguments that MVP should be only like application centric, but there's nothing stopping you from using MVP. If you just literally need a dumb interface, like a straight up website here, I mean, this is Google Slides, right? The interface is this full screen presentation. You could use it. It just depends on what you want to show or how you want to handle things. So a point that kind of came up in the last class, which is interesting that I'm going to touch on, is would the user get a different experience if it was MVC or MVP? Or furthermore, like, would they get a different experience if you are, using an observer versus a visitor? The user is not going to care. The user will never see this, right? All the user ever sees is what is rendered to their screen. All the user ever sees is what you render to their phone. They will have zero appreciation of the backend. And the backend is going to be whatever is behind the screen being executed. What you are doing here with all these design patterns, not just MVC or MVP, you are putting on your software project manager hat or your software engineering hat, and you are structuring your project to make life easier for yourself and for your teammates and your project team. If you just hack something together super quickly, it's going to work. But if you spent an extra hour implemented MVC, then your entire team can work on the web page at the same time. Or if you decide to add another view later on, you don't have to rip apart the entire code base. I gave an example in the last class, and I'm going to show it again here. I started playing around with some text generation in my little game here. And I just wanted to basically start working on that aspect because I'm not going to get the whole thing done by the end of the semester. But here's my little terminal-based GUI. So I've got my map over here. I've got a title. I've got a description, and this is going to be all procedurally generated. So I move east, I move east, I move down, move east, I move up. I'm not sure where I can move up and east. I think it's there. No, you won. I found the MacGuffin and I escaped or whatever. Something I hacked together and not very long. What I want to do, though, is I want to take all that code, not this one, sorry, clear, Python, camera. All right, so all this code, I want to be in here. When I'm in this area, I want to be in a field of wheat. When I'm here, I'm getting into the woodlands. Here I'm in a dark ocean or something like that, right? I've bumped into the war duck of peril or something of that nature. I've got these two very separate projects that I'm working on. Now I need to bring this all together. Well, what you see are two different views. I've got a terminal view, which is a very cell-based, traditional terminal-like game. And I've got this nice graphical entity. How in the world am I going to merge these two without completely tearing apart both code bases? You see what I mean? My data store in this case would be all my text I've generated. Which text is tied to which objects? What do I show when I'm in this area? If I had implemented this correctly, I wouldn't have to go back and refactor both code bases. I could just tweak my view and I'm golden. But now I've basically saddled myself with all this extra effort, but I got a quicker prototype there. And again, here, this is something that doesn't take one person very long, but think of a real world project with a large team. And if you can separate out your responsibilities nicely, you can very easily make your project completed sooner. And kind of the drab and boring side of programming, but you have to start thinking about these things. Okay, so enough review. Let's talk about anti-patterns. Now, there are a lot of them out there. And anti-patterns. So I've got a link to the Wikipedia page here for them, because this is actually a pretty good list of all the anti-patterns we see out there. Let me zoom in a little bit here. So we're going to talk about a few of them momentarily, but they're all nicely broken up by category. So here's a fun one. Death March. This is a project management anti-pattern. A project whose staff, while expecting it to fail, are compelled to continue, often with much overwork by management which is in denial. So think of any video game you've ever heard of where it's set up to fail, and yet they're forced to complete it anyway. Like what, Fallout 76, or any of the newer games that are horribly derided. I'm sure there are people that love Fallout 76. But the point is, this is a well-known anti-pattern. We have a project that has to get done. Everybody hates working on it. The only way to get it done is by working horrible overtime. And our managers don't care, or they're ignoring the problem. This would be a death march, something to avoid. Something that if you are experienced in working, you can probably smell from a mile away if you're a project engineer. All right, so let's look at another one. Which other one did I want to talk about? Ooh, here's a good one. Magic numbers. Simple. Look at your code base. If you have a number just appearing out of the blue, it's a magic number. Nobody knows what the heck that number is there for. In about 2 days, you yourself will forget about what that magic number was for. However, if you have an explanation for why it's this value, or you have the ability to change it, then it's not a magic number anymore, then it's a explained number, we know why it's there. So basically, I would highly recommend, honestly, I would advise you all to check out this page and look through some of these patterns, because I can guarantee you probably have done some of these yourself by accident. And the point of this list is not to make you feel bad about implement as many as we can. There you go. You know what? Implement as many as you can, have the most successful term project, and then I will be quite surprised. But these are things that people have seen time and time again as being problems to avoid. So kind of understanding what's out there and how to avoid them is really a good thing to do. All right, so at 1:47, I want to talk homework briefly, so I'll try to stop before then. So here is a few examples for you of some of these patterns in a little bit more detail. Let's start off with the God object, or the God class. I've mentioned this one before. You probably did this as your first ever programming assignment, and you probably still do because it's easy. But basically, you have a class that does too much, or it knows too much, or it has too many responsibilities. If you remember last time we touched on cohesion of classes, this is where your classes should be very narrowly focused, right? They should have like one job, and they should do that job well. If you need to bring in other functionalities, you should inherit from other classes, you should extend them or import them. Basically, your class should not look like this right here. Right, so here is a class for a manager of employees. I can hire people, I terminate them, I edit them, I can give them vacation time, play their addresses, give them equipment, dock their pay, add their schedule, etc., etc., etc. Again, look here. There's even more because this is snipped out. This is a very poorly constructed class because it is just doing too much. Now your question is, well, does it work? Probably works just fine, but it's not easily maintainable. It's very busy. If I make one change in my program, I'm probably going to have to update this one too, regardless of where that change is made, just because it's doing so much, so many things. So if you see something like this, break it apart into multiple classes. Have them associate with each other in a way that makes sense, and then you have a much cleaner program. Again, classes should be focused. They should have single responsibilities. Highly cohesive is the actual term. So don't do God objects. And the reason why I said not to pick on anybody, but why this was probably your first program, was that you learned how to write a Java class. You put everything inside that one class, right? And that's it. You didn't make separate class files. You didn't do all this stuff. Yeah, maybe you did, I'm not sure, but My guess is that for ease of use, everything was just in one file or one place. I still do this sometimes, by the way, so don't like think I'm saying it's impossible. All right, second one. Let's talk about the big ball of mud. This is a project where it's effectively spaghetti code. And spaghetti code is basically a big mess of code that has no rhyme or reason. It's very frantically implemented. It's very hard to read, and basically it's just very poorly constructed. So here I've got a nice little picture of all these separate classes and integrations and separations, and nobody knows who is responsible for what directly. Basically, it's just a big old mess. Why does this happen? It was designed quickly, maybe it was designed haphazardly. Effectively, you have something where there's not a lot of thought put into it. You just keep slapping on modules and hope it works. Other signs, you might have a lot of duplicate attributes or duplicate methods, meaning that, like here, quote, quote detail, components, these might all have the same fields, for instance, and the same functions. And that's bad, because then you're going to have duplicate data possibly. It's not going to be consistent. It's going to be a mess. Other sign here, too, it might be that everybody's methods and attributes are public. Hey, it's a lot easier if we just make everything open to everybody else, right? Yes, it's easier, but it's also quite possible to have horrible consistency problems, to have security flaws, to have all kinds of issues that basically undermine your program. Things should be properly hidden, they should be properly, tagged with whatever visibility they need, not for ease of use, basically. This is a fun one because I can point to myself for this. So there's the law of the instrument. So this is your silver bullet. It's going to solve all your problems. This is an algorithm. It is a design pattern. It is a class definition. Basically, it is something that you always use over and over and over again because you know how to write it and you know that it works. The quote here I've got is this standard computer science idea for this, especially if you get into algorithms, where if you know how to use a hammer, every single thing that you see is going to look like a nail. So I'm going to hammer in my screws. I'm going to hammer in my staples. I'm going to hammer in my nails. I will hammer in any kind of a fastener. Is it the right tool for the job? Nope. But will it work? Mostly. If you hammer a screw, you kind of break the threads or you break the wall, right? But you still get it fastened, so that's good, right? What happens here is that you get put into a comfort zone, right? So you get really comfortable with something, and then you just keep reusing it because I kept trying it and it kept working. So let me point the finger at myself. In my fun/research life, I like to play around with search algorithms. So I like to find solutions to problems. I started off with genetic algorithms. It's a nice little search algorithm, lots of fun. Developed at U of M for anybody who cares about algorithms developed in Michigan. Basically, it is a nifty evolution-based search algorithm. Now, the problem is that I use it for everything that is a search problem, even when it doesn't make sense, because I like GAs. If I have a problem where I could very easily apply something else, like there's numerical optimization methods where through mathematical formulas and basically implementing calculus and all that fun stuff, you can very easily and quickly find the answer to a problem. Well, I'll probably still apply a GA because I like my GAs, even though it's going to take 3 times as long and maybe not even give me the right answer. So try to avoid getting comfortable is kind of the takeaway because you can very easily get stuck in a rut with this. And what you might see is that maybe it doesn't always work. Maybe you get the wrong answer. Maybe it's a lot slower, less performant. So just things to kind of watch out for there. Another one, cargo cult programming. This is another fun one, kind of in the project management side. So a cargo cult is actually something that happened around World War II, which is like this was a real world thing and we kind of coerced its terms into programming. Basically, some of the natives on the islands that were visited during World War II did not understand what airplanes were or runways were or convoys or any of this fun stuff. They just knew that these magic planes appeared out of the sky and delivered supplies. So what they did was they mocked up runways. They mocked up like military installations, and they hoped that the mystical airplanes would drop off supplies later on. So this is known as a cargo cult, and how we coerce it into programming. This is where you include practices or principles or algorithms or program designs that you have no idea what they're doing. You're just going to assume it's going to save the day. So let's follow some magic process. Let's apply this magical algorithm where we have no idea what it's doing, but we get the right answer. Or let's all of a sudden be extreme programmers because that's the new buzzword and it's going to solve all of our project management problems. Probably going to find it's not going to work like you thought it did. It's actually going to probably introduce more problems because you don't actually know what's going on. All right, last one, dependency hell. This is another fun one where here we just have so many dependencies it's unmanageable. And honestly, let's look at these figures. This probably looks like a typical Node.js and NPM installation anyway right now. But think of all these as modules with version numbers, with file sizes that take up space in your program, and you're importing them all. You can very easily get lost in associations, mismatches in version numbers, bloated file sizes. Basically, it's not a good thing to get into. Try to minimize your dependencies if you can. Don't just like throw in import statements or throw in includes or extends if you don't need them. Kind of the canonical example is including the boost libraries in C++. Hey, thank you about that. Just there's so much stuff coming in that you don't need. Hey, look at that, multiple reminders. It's time for me to stop talking. Wow, actually I have to keep talking. We're done anyway, so that's fine. So we have some homework that I put up last night. I'm going to have you all do some programming for me. So this is going to be probably the only project where it's programming related and not specifically tied to your term projects. But I wanted you all to get some experience with design patterns and implementing them. And honestly, I didn't want you to break your term projects by playing around with some of these things, so I thought we'd do something separate. So your job, you've got 2 weeks to do this, so I'd get started early since it's programming and implementation. I want you to implement an MVC pattern. So I've got a problem here for you to follow, and I've got some details, so make sure that you read through these. Basically, I'm having you make me a storefront where I'm making STEM toys for kids, for instance, and I need 2 different views. So I need a product listing view and a product detail view. So think of it like you show a list of products, I click a product, I see detailed information. And there should at least be 3 objects created. And what kind of I'm trying to get across here is that I'm looking for more of a mock-up or a prototype. I don't want a full-blown web application. I don't want a super deep and detailed, Android application. Just do something simple that shows the clear separation of responsibilities. So if that kind of makes sense, basically. When I describe a problem like this, I could see easily how people could take that and run with it and go crazy. Like, you don't need to do a massive Django application or throw Code Igniter up there or anything like that. You can if you want, it just depends, I suppose. I don't have any restrictions against frameworks in here because they take some customization. Like Code Igniter took me probably several hours to get up and running, and that's just because I'm not used to it anymore with their changes. I guess if you're concerned, just ask me if it's okay. More than likely it will be okay. But what I'm looking for is a class diagram, so you have to make a class diagram of your implementation. So lay out exactly the classes, attributes, methods that you are using. I want the code to be well commented, that I can see exactly what each class file is doing. I should be able to execute it, so tell me how to run it as well. So instructions on running your code, language, modules, version numbers, anything I need to install. And then I want some screenshots as well, in case if I can't get it up and running, or so that I can follow along with what you did. Again, the one takeaway that I want you to read here, though, is that, where is it? Here. I don't care what programming language you use. You can do this in Python on the terminal. You can do a Java Swing application. You can do it in Android. You can do it on the web. I don't care. I just want it to be something you're comfortable in and something that you can do without taking hours to learn a new language, basically. So, realize I'm a minute over now. Everything clear on what I'm looking for here? If you have any questions, feel free to email me or message me or anything like that. So, but 2 weeks, MVC pattern, online store for storefronts, can be terminal, can be graphical. As long as you show me clear separation of files and responsibilities, I'll be happy. All right. Other than that, all right, cool. Yep. Okay. Well, I hope you all have a good day. I will see you Wednesday. Is this, yes, this is individual. So everybody has to do their own for this one. Force you all to do something technical. So I suck. Yeah, you don't have to use GUIs. Hell, you could do this in assembly if you want to go crazy. I'll give you nerd props for that though. Alrighty. Anyway, I will see you all Wednesday. We will start talking about object-oriented programming a little bit. Bye, everybody.